Hey everyone, and welcome to our FRC programming course. My name is Alland, and I'll be one of your primary instructors, but alongside me will be Griffin, who will also be co-teaching this course alongside me. So this video is going to be a pretty comprehensive introduction to talking about, what FRC is, what you really need to know when coding an FRC robot, and sort of the things to expect when actually going ahead and completing this course. So let's get started. So first of all, what is FRC? For those of you who are absolutely brand new, what is it? Well, FRC stands for First Robotics Competition. It is designed for students in grades 9 through 12. And basically the idea is every January they come out with a game that your robot is responsible for playing, right? And so every January you'll meet up with your team, you'll see the game, you'll see how it works, and then from there, you'll design a robot to complete that game. So what does the game look like? Well, it's actually 3 robots versus 3 robots. So there's a blue alliance and a red alliance. So the blue alliance goes against the red alliance. Now, the specifications of which 3 robots and how they get picked will depend on the strategy and the competition. So that'll depend on where you are. But generally, it's 3 robots versus 3 robots with a blue alliance versus a red alliance. Robots on each side, so on each alliance, will work together to complete tasks and get points. And whoever gets the most points wins the match. So there are 2 main parts of a match that you need to know. The first part is autonomous, right? So this first part I'm referring to is the first 15 seconds of the match. And this is where the robots do tasks on their own. Then we also have teleop, which is the remaining 2 minutes and 15 seconds. So if you do the math there, a match is 2 minutes and 30 seconds, right? So the remaining 2 minutes and 15 seconds is where human drivers from each drive team, so every robot has a drive team, right? And the human drivers will drive the robots with their controllers. So what exactly makes up a robot, right? Because that's kind of the big question that we need to answer in order to actually understand the parts that we need to code, right? So the first sort of perspective I want to offer is the programmer's perspective, right? So from a programmer's perspective, you're coding this microcontroller, which you can think of as a tiny computer if you're unfamiliar with that term. You're going to code this tiny computer with motors and sensors, right? And then from a general perspective, it's a bunch of different mechanisms that are designed to perform certain tasks within the game. So I'll give you an example from 2022, where the robots needed to shoot balls into this central hoop, if you will. And so you would have this shooter mechanism that would basically spit out the balls and shoot them into the goal. You'd also have this intake mechanism that would suck in the balls into the robot so that the robot could eventually shoot them, right? So that's your general perspective, and that's what I mean. So here's some important notes on both of these perspectives, right? So the first thing is that the microcontroller, just to elaborate on what I said there, is a computer that is responsible for sending commands to the different motors and sensors on the robot. The microcontroller, or the tiny computer that we use in FRC, is called the Robo-Rio, and our job, right, is to write code for the Robo-Rio so that we can send signals to motors and get signals from sensors, all right? So beyond just coding a robot, right? Because that's kind of obvious, right? As a programmer, you need to code a robot, right? There are some other things that you need to keep in mind. So FRC is incredibly collaborative. And so a main part about working with an FRC team is to work with other team members, especially those who aren't directly involved with programming the robot, right? Because you might think that, okay, if I've got me and my friends and we're all programmers, right? Shouldn't I be spending time with them? Well, not entirely, right? Because in order to understand what exactly you need to program and how you should be programming it, you need to understand the robot's wiring and mechanical constraints. Now, for the purposes of this tutorial, we're going to introduce you to certain mechanisms that'll give you a very good understanding of, okay, this is what I need to expect when I look at a robot and its wiring and its different constraints. So we're going to introduce you to all of that. The next thing is you need to collaborate on different robot strategies. So something cool about the FRC games is that in the autonomous period, your robot can start in any spot that you choose to. So think about it, right? There are 3 robots on one alliance, And the three robots are going to usually do different things, right? Because they're starting at different places on the field, right? So depending on the robots and what they can do, you might have to run a different autonomous routine. So a very, very basic example is think about a robot that could shoot balls versus a robot that can't, right? The robot that can shoot balls should obviously in autonomous go and pick up balls and shoot them. But a robot that can't, right, should probably work on something else that might be advantageous later on, right? So the idea is that in autonomous, you're not just running one thing repeatedly in every single match, right? There's actually a real possibility where your robot might have to do something different depending on the other robots that you're working with, right? And finally, the last thing, and I just included this here because I think this often gets overlooked, but you're going to need to troubleshoot and be able to write code fast during the heat of competitions and the competition season. So this involves things like debugging, fixing problems, adapting if anything breaks on your robot, etc. So we're going to introduce you to all the common practices that you'll need to know for this. So what exactly does coding a robot entail, right? So I already mentioned that we're going to be writing code for this thing called the RoboRio, which is the tiny computer that sends signals to your motors and sensors to actually do things, right? So beyond that, you might be wondering, well, okay, I've seen these different coding languages before, right? So which one do we use? Well, we're going to be writing code for our robot with Java. But here's the thing, right? Like if you've worked with Java before, right, there's no specific robot code that you can actually use, right? Like there's no like motor, my motor equals new motor, right? That doesn't exist in Java, right? So there isn't anything Java has that lets you start spinning up a motor or writing code for the RoboRio, right? Like, yeah, you have to think, like, how would I even, like, actually send my code to the robot in the first place, right? Like, how do I do that with Java, right? So this is where we use a library, right? So if you know your import statements in Java, right? Like when you import ArrayList, for example, right? It's a similar idea, right? We're going to be using a library, which for those of you who aren't super familiar with code, it's an add-on to Java called WPIlib. And so this gives the ability to write Java code and to command specific parts of a robot, so things like motors and sensors. There's also additional tools included with the WPIlib that lets you send code to the robot, simulate robot code, which is what we're going to be doing a lot, and build your robot code. And by building, I mean just compiling it to make sure it's valid for a robot. So here are the things that you'll need for this course, all right? The first thing is knowledge of Java. This is not going to be a Java 101 course. I would highly encourage you to check out the course webpage if you don't have any experience with Java, because we're going to include some really useful resources that you can use. So I would highly recommend that if you're unfamiliar with Java, go to the course webpage, look at the resources, do those first, and then come back here, because then you'll have a much better time with the tutorial. The next thing that you'll need is a Windows computer. And as of August 2024, where Windows ARM computers are at their peak right now, it cannot be one of those. It has to be with like a dedicated Intel core processor, essentially. It cannot be an ARM computer, because as of August 2024, WPIlib does not support, not WPIlib, but the game tools needed for FRC are not supported on ARM computers. And if that changes, we will make a note, and so keep track of that note. But for now, if you're watching this as of August 2024, it cannot be an ARM computer. You will also need a video game controller. Now, this is where it gets a little interesting, right? Because, like I mentioned before when I was introducing the elements of an FRC match, right? Drivers use controllers. And so, as a programmer, if you really want to get your hands dirty and actually simulate the robot code at home, so you have a better understanding of what's going on, you will 100% need a video game controller. Now, keep in mind, you can still follow along with the course. So there's no need to actually simulate the code. If you just want to understand the code, you don't need a video game controller, okay? But if you're really looking to get your skills to the next level and really understand what's happening, a controller makes interacting with code so much easier. Another thing that you'll need, that I recommend is if you don't have a controller, see the course webpage for some recommended controllers, because they're actually not too expensive. You can get a really good controller on your hands for like 15 to 20 bucks. So we'll recommend some controllers that you can use on the course webpage. Now, as a last thing to note, for those of you who might have a little bit more experience with FRC or just seeing if this course is for you, this course will only be working with the CTRE API. So if you will be working with Rev components, the skills that we talk about are definitely 100% transferable, but the syntax is going to be different, and you might either want to look at a different tutorial that exists if it does, or check out the Rev documentation for more details. So that's it for this video. Thank you so much for watching. I look forward to seeing you in a future video.